Hi folks, today we're going to be continuing simplifying rational exponents. Now, in this first problem right here, we have the cube root of 64y to the sixth. So there's two different entities underneath this root, so we need to just go ahead and begin by breaking it apart. So we have the cube root of 64, and we also have the cube root of y to the sixth. Now, we're going to work each problem independently. Alright, so we start off with the cube root of 64. And if we go back to that list I gave you, the cube root of 64, that's just 4. Now this other part here, the cube root of y to the sixth, basically that turns into a division problem, because if we were to rewrite this in rational exponent form, this would be y to the 6 over 3. Alright, and then 6 divided by 3, that just basically breaks down to y to the second. So what our answer then would be is just 4y to the second. So we just want to take a look at how many times does this 3 go into 6. And it goes in exactly twice. Alright, so that's pretty much it. That's our answer. Now on this next one, everything in the parentheses is multiplied. So this exponent that's on the outside is going to come to each part. Alright, we can't not forget that it goes to that 27 as well. So we would have 27 to the 1/3. P to the, now these exponents are going to multiply. 3 times a third is just 1. And then the Q to the 12 times 1/3, or 12 divided by 3 would be 4. So the only thing really left to figure out is right here, 27 to the 1/3 power, which is the third root of 27. And again, we go back to that list, the third root of 27 is 3. So we have 3 p q to the fourth. And there it is. Okay, we're just simplifying it down. On this next one, we are going to want to break that apart. We want to break it apart as much as we possibly can. So break apart the numbers, the x's, the y's, the z's, all that stuff. So we're just going to focus on a lot of different problems here all at once. Alright, so we're going to start out with 14 over 2. Times. Then we move on to the x's. We have an x over x to the 3/4. And then we have a y on top, so y to the 1/3, but there's no y's on bottom, so that's just going to be over 1. And then we have no z's on top, but we have a z to the -6th on bottom. Now, simplify each part. So 14 divided by 2 is 7 over 1. The x's. We have x to the first on top, x to the 3/4 on bottom, so it's just subtract. Top exponent minus bottom. So x to the 1 minus 3/4 would be x to the 1/4 over 1. Our y's, there's nothing that's going to happen there, so it's just y to the 1/3 over 1. And then our z's, this has a negative exponent, so it flops to the top, becomes z to the +6th over 1. And now we can just throw it all back together. So our final answer would be 7 x to the 1/4, y to the 1/3, z to the 6th. And there it is. It's done. Coming over to this fourth one, the fourth root of m to the 4th n to the 8th. So we can break that apart. The fourth root of m to the 4th over the fourth root of n to the 8th. So now, just like the first one that we got done doing here, it's only a matter of how many times does 4 go into 4. Well, on top, 4 goes into 4 exactly once, so the top is just going to be m to the 1st. And on bottom, 4 goes into 8 exactly twice. So on bottom, we have n to the 2nd. And that is finished. The next one, the fifth root of 4, a to the 8th, b to the 14th, c to the 5th, we are going to break that apart. Lots of little problems instead of one big problem. So fifth root of 4 times the fifth root of a to the 8th times the fifth root of b to the 14th and the fifth root of c to the 5th. So now it's just a matter of how many times does it go in. So the fifth root of 4 here, nothing happens with that. Nothing is going to happen with that because the lowest number we can have under here would be a 32. And that's 2 to the 5th. So nothing's going to happen with that. So that is just going to stay as the fifth root of 4. But now, with this next one, how many times does 5 go into 8? All right, it's going to go in one time. So an a to the first is going to come out, and then the stuff left underneath, 8 minus 5 would be 3. So there's going to be 3 left over. So an a to the third is left under the root. The same type of thing with the b's. 5 goes into 14 twice. So we can bring out b to the second. And then left underneath would be b to the 4th. And then 5 goes into 5 exactly once for c, so we would just have a c. Now, there are all the things that were broken out of the root. So we have a, b squared, c, and then left underneath that fifth root, we have a 4, a to the third, and a b to the 4th. And there's our answer. Now keep in mind, when you're simplifying, it doesn't mean that you're writing it in a way that looks easier. Simplifying means you simplify. You break out what you can, you break down what you can break down, and then you leave the rest of it. Now the next one, the third root of x over y to the 8th, again, we can break that up. Third root of x over the third root of y to the 8th. Now on top, that third root of x, we can leave that. But on bottom, the third root goes into 8 twice, so we can pull out a y to the second. And then there will be 2 left over, so cube root of y squared. And we will just leave it like that. We will leave it with that third root of y to the second on bottom. I know we're maybe breaking a little bit of a rule having this root in a denominator, but that's fine. We can leave it for now. So I will leave these last two for you to do on your own. And if you do them right, the answer for this first one would be 3q to the third. And this one would be x squared over y. So I challenge you to give those a try. As usual, we need to make sure that we're practicing this. So here you go, page 425, numbers 43 to 59. Skip number 51. I wish you the best of luck. We'll see you in class.